so we have the following identity that we're going to prove. So pick the most complicated side to work with. I don't know. I think I want to work with this side because I want to multiply by the conjugate of the denominator and see where that takes me. So let's see. Let's start with that side. I've got 1 minus cosine theta over 1 plus cosine theta. I'm going to multiply the top and bottom by the conjugate of the denominator. So that would be 1 minus cosine theta over 1 minus cosine theta. So let's go ahead and multiply. Foil these out, and I would get 1 minus 2 cosine theta plus cosine squared theta all over 1 minus cosine squared theta. Okay, why did I do that? Well, I did that because a lot of the times that will bring me to this, to an identity, 1 minus cosine squared. 1 minus cosine squared, I can replace that with sine squared. Maybe that will help me, maybe it won't. So I will go ahead and replace that. And I'm trying to get here. Okay. I think I'm going to divide everything by sine squared and see where that brings me. But again, we have to make some room on the board. So I'm going to go ahead and divide everything by sine squared and see what happens. And why am I thinking of doing this? Well, because where I want to go has cosecants and cotangents. So they are, cosecant is 1 over sine, hello, and cotangent is cosine over sine, okay, starting to look like that. So I've broken it up. I've divided each piece by sine squared. And now I'm going to rewrite them in terms of cosecants and cotangents. Because 1 over sine squared is cosecant squared. And I'm not sure how I'm going to break this up. I'll come back to this. But about this, cosine over sine, both being squared, is the same as cotangent squared. All right, so I'm going to break this guy up. I'm going to make it minus 2 cosine theta over sine theta times 1 over sine theta. So I just pulled them apart a little bit. Do you see? Sine times sine is sine squared. Cosine times 1 is cosine. And now I can see that this here is cotangent. And this one here is cosecant. So let's rewrite that. I got okay, need to know how to spell it. Cosecant squared minus 2 cotangent theta. 1 over sine is cosecant theta plus, forgot the plus sign, cotangent squared theta. And I think I'm there. Look, if I factor this, I should have cosecant theta minus cotangent theta squared. Can we fit it in without erasing? Cosecant theta minus cotangent theta squared. Because cosecant theta, well, let's do this. Cosecant theta times cosecant theta minus cotangent theta. Cosecant times cosecant is cosecant squared. Cotangent times cotangent is cotangent squared. Then we have minus cosecant cotangent minus cosecant cotangent, which is 2 of them. So that's the way it factors. Now that we can see that, let's write it how the answer is written. Cosecant theta minus cotangent theta squared. And we did it. All right, we have another identity to establish, and we need to pick the most complicated side, which I don't think I could do much with that, so I'm going to start with this side. And I think I'm going to change these guys to sines and cosines. Okay, so I'm going to rewrite it as sine squared theta minus tangent. I'm going to write as sine over cosine all over cosine squared theta. I'm going to write cotangent as cosine over sine. Okay, Now I have a complex fraction. So I want to get rid of the complex fraction. So I'm going to multiply the numerator and the denominator by the LCD of the little fractions. So I'm going to multiply by cosine times sine. So let me multiply the numerator and denominator by cosine theta sine theta, cosine theta sine theta. So I'm going to multiply the numerator and denominator by cosine theta sine theta. Okay, so what's going to happen? When I multiply that with sine squared, that would be cosine theta sine cubed theta minus, and what happens when I multiply it with this fraction? The cosines would drop out, so then that would be sine squared. Okay, right? Because the cosines dropped out, and that would be sine times sine. What about on this bottom one? Cosine theta sine theta times cosine squared would be cosine cubed sine theta minus, and then what happens here? The sines would drop out, and I have cosine squared. All right. Whew. Now what? How is this ever going to be tangent squared? Well, what if I factored out the sine squared in the numerator and I factored out the cosine squared in the denominator? I don't know. Let's see where that will bring me. Will I have enough space to do it? I'm going to try. So I'm going to take out cosine. No, on the top, I'm sorry, I'm going to factor sine squared. So that would be cosine times sine minus 1 all over. And on the bottom, I'm going to take out cosine squared. Cosine squared theta. That leaves cosine times sine minus 1. This is looking good. All right, so what did I do? I took a sine squared out of the numerator, and I took a cosine squared out of the two terms in the denominator. I think we've got something here. What happens to this factor? It cancels, and we're left with sine squared over cosine squared, which is equal to tangent squared. Okay, I'm fitting it all on this page, so that would be the fourth step. We have sine squared theta over cosine squared theta, which is tangent squared. We did it. So what are some things I did? I changed everything to sine and cosine. When in doubt, change everything to sines and cosines and see if that gets you anywhere. Then I had a complex fraction, so I multiplied by the LCD of the little fractions inside the complex fraction. Then I factored. I wasn't sure if that was going to bring me anywhere, but it did, because I could simplify. By factoring, I was able to simplify this fraction, which left me with sine squared over cosine squared, which is tangent. Oh, okay, we have an interesting identity here. I think this is more complicated. I see two fractions, so I'm going to get the LCD and try to add them together. Maybe that will bring me somewhere. So what's the LCD? The LCD is 1 minus sine theta and 1 plus sine theta. So my first step, I'm going to multiply this fraction by 1 plus sine theta, and I'm going to multiply this fraction by 1 minus sine theta. Okay, so let's do that. So we've got 1 plus sine theta over 1 minus sine theta. And this gets multiplied by 1 plus sine theta over 1 plus sine theta minus 1 minus sine theta over 1 plus sine theta. And that's getting multiplied by 1 minus sine theta over 1 minus sine theta. All right. So why don't we go ahead and FOIL this out and FOIL that out. You know, this would be have parentheses. Okay, so let's do that. Oops, I don't want the red. That'd be 1 plus sine theta plus sine theta, so 2 sine theta plus sine theta squared over 1 minus sine squared theta. They are conjugates of each other, or if you multiply it out, 1 times 1, Positive sign minus sign, so the outer and inner term drop out, minus sine squared. And then what do we have here? 1 minus sine theta, another sine theta. That's 2 sine theta plus sine squared theta all over sine times sine squared over 1 minus sine squared theta. So they have a common denominator, which we can add them together. But be careful, they're being subtracted. So I'm actually going to distribute the negative sign and add these together. So it'll be 1 minus 1, so the 1's gone. And then it would be positive 2 sine minus minus 2 sine. So how many sines are there? 4 sine theta. And then we have positive sine squared minus sine squared, so the sine squared's dropped out. So we have 4 sine theta over 1 minus sine squared theta. All right, what am I trying to prove? Always keep looking back up to see what you are trying to get to. And we're trying to get to 4 tangent theta secant theta. Okay, tangent is sine over cosine, and secant is 1 over cosine. Oh, how about this identity? 1 minus sine squared. 1 minus sine squared is the same as cosine squared. So let's replace that, see if that helps. And I think we're going to be there. I think if I break this up, instead of saying cosine squared, make that cosine times cosine, and then you'll have sine over cosine, which is tangent. So let's break this up. 4 times sine theta over cosine theta times cosine theta. Right? What do we have here? That would be tangent. And what's here? Well, there's no number there, but technically that would be 1 over cosine, which is secant. Yay! And we have it. Except I don't have enough space. So let's see if we can squeeze in number 6. Step 6 here. 4 tangent theta secant theta. Sorry, it's messy.